By now, you should understand what a Bronsted-Lowry acid and a Bronsted-Lowry base are. And what I wanted to introduce you to in this video is the idea of what is called a conjugate. You see, when we're dealing with acid and base reactions that follow the Bronsted-Lowry rules, acids are proton donors. Bases are proton acceptors. Remember that proton represents just an H plus being given up in the solution. The one thing you may have noticed when you watched me do these reactions in previous videos is that I made them reversible. And that's because they are, for the most part, reactions that are acid and base reactions are reversible. This means that the reaction is also going in this direction. And it means that we actually have a proton donor and proton acceptor on the opposite side of the equation. So if we take a look, H3O plus is reacting with Cl minus. If we look at it going this direction, it means it's making H2O and HCl. So what has to be taking place is a hydrogen from H3O plus is being given to Cl minus. In other words, that means H3O plus is acting like an acid. But because it looks very similar to OH, and because it is basically derived from OH and H2O, and the H2O is derived from H3O plus, it is considered to be a conjugate acid. A conjugate acid is the acid on the product side of the equation, and it should always look very, very similar to the base that is on the opposite side of the equation. The Cl minus, on the other hand, well, it's actually accepting a proton. It's accepting that proton from H3O plus and becoming HCl. That makes it a base, and since it is on the product side of the equation, it's considered to be a conjugate base. And if you notice, it's only one proton different from HCl. Every reaction that we look at in Bronsted-Lowry chemistry that involves these types of acids and bases must have a conjugate acid and a conjugate base. And for students, this becomes a little bit tricky for them to identify, so I wanted to show you a really quick trick to help you be able to identify Bronsted-Lowry conjugate acids and conjugate bases. So what I have here is just a chart of some different substances. And for each, what we're going to do is figure out the conjugate base and the conjugate acid. Let's start by figuring out the conjugate acid of each of these substances. In order to change any substance from what it is to a conjugate acid, what you need to recognize is that this substance would have acted as a base. And since it would have acted as a base, it means that it's going to accept a proton. So what that means is we need to add a hydrogen and we need to add a positive charge to whatever that substance is. So let's take a look at our very first example. We have HPO4 with a -2 charge. In order to figure out the conjugate acid, we need to add another H. So this becomes H2PO4. But we also had this -2 charge, and we have to add an H plus, since when it acts as a base, it actually gains a proton. And remember, a proton also carries a positive charge. So a -2 charge and a +1 charge is going to create a -1 charge. So the conjugate acid of HPO4 negative is H2PO4 negative. If we do the same thing here, HSO4, well, we need to add another H, so H2SO4, and there was a -1 charge. We need to add a +1 charge. That's going to give a charge of 0, so we don't even write anything in the top corner. Now, HCl, we would add another H. So H2Cl, we need to add a positive charge, and we get H2Cl+. I want to mention, if you know your chemistry, you probably know that this is not likely. HCl is an extremely strong acid, and it's very unlikely that it's going to act like a base. The only way that this happens is if we actually mix it with something that is an even stronger acid. And in our last example, we have NO3 negative. So we need to add an H. We get H, NO3, and -1 plus the +1 charge from the proton, we get HNO3. So when we need to go from a substance to its conjugate acid, we just have to add that H plus to it so that we can figure out how to do that. Now let's take a look at conjugate bases. Now in order to go the other way, to change something from that substance into a conjugate base, well, you have to remember it would have acted like an acid. And if it acted like an acid, what that means is it's going to donate an H and donate a positive charge. So we actually need to subtract the H and a positive charge from that substance. So HPO4, we're going to lose an H, and so now we just have PO4, and we also lose a positive charge. So instead of -2, it becomes -3. HSO4, same thing. We're going to lose an H and lose a positive charge. So -1 becomes -2. HCl, we're going to lose that H. We're just going to be left with Cl with a -1 charge. Again, you had 0. Subtract that positive. Here, there is no conjugate base. And there's no conjugate base here because there's no H to donate, which means this is not able to act like an acid. NO3- is not an acid because it has no H's to donate. So when it comes to any Bronsted-Lowry acid and base reaction, there has to be conjugate acids and bases on both sides of the equation. And in order to find those, we can just add or subtract that H plus from the substance in order to figure out what those would be. So hopefully this helps you get a handle on what Bronsted-Lowry acids and bases are and how to work with them in a chemical reaction. So thanks for watching, and I'll see you next time.